Okay, so here are the different words that you're going to see today. So just keep an eye out for these. We will review them at the end. Um, but here is just a review of those different words. Okay, so let's look at the angle measures of regular polygons. So let's recall that a regular polygon can be broken into congruent isosceles triangles, like you see here. Based on this, what we're able to do is find the central angle of all these individual isosceles triangles that we're creating, and we're able to find the measure of each base angle of the isosceles triangle. So the way that we would solve for the measure of these central angles, oops, give me 1 second. Okay, let me make sure. The way that we'll be able to solve for the measure of these central angles is if you think about it, inside of this regular octagon here we have a circle, right? A circle can exist on the inside. And what we know about a circle is that the circle is equal to 360 degrees. The entire outside of that circle is equal to 360 degrees. And so that being said, what we can do is we can take 360 and divide it by each of the angles on the interior. So 1, 2, 3, 4, 5, 6, 7, 8. We're also able to tell that it's 8 because we do have an octagon which has 8 sides. And we're creating those triangles using those sides. But basically, now you know that you have 8 central angles inside of that entire circle. So you take 360 divided by 8 is 45. That being said, each of these central angles are equal to 45. Okay, so that's pretty simple. But now how do I find the measure of each base angle of the isosceles triangle? So I'm looking for the measure of these base angles. Well, what I know about isosceles triangles are that isosceles triangles have 2 congruent base angles. And what I know about triangles are that triangles are equal to 180 degrees. And so that being said, what I can do is I can take 180 degrees, subtract it by the central angle that I just found, and divide by 2 because those 2 base angles have to be congruent. So basically what I'm just doing is I'm taking 180, subtracting this, 45, and then dividing by 2 because these would be congruent to each other. So I have to split up the remainder of my angles measures available and divide them by 2. So I have 180 minus 45 divided by 2. 180 minus 45 is 135. And so basically what I'm saying is I can take that remaining angle measures, that 135, and I need to divide it by 2 because those 2 base angles are congruent to each other. So divide that by 2 is equal to 67.5, which tells me that each of my base angles is equal to 67.5. Okay. Any questions about how I solved for the central angle here or how I solved for the base angle? Concerns? Okay, so that being said, now what I'm going to get into is how do I actually find the area, the total angle measures of, or the total measure of these regular polygons. So what we're going to look at is the apothegm and the area. An apothegm of a regular polygon is a perpendicular segment from the center to the side of the polygon. So this would be the apothegm. And basically it's a perpendicular segment, so it's perpendicular to the center and the side of the polygon. Well, given this, what we're able to do is we're able to solve the area. If we are given the apothegm, all we have to do is, in order to find the area, we do 1/2 times the measure of the apothegm times the perimeter. So the area of a regular polygon is half the product of the length of the apothegm and the perimeter. And so we'll see how we can find the area given this information. So here's an example of a problem where we're going to use this equation. And this one says we have a regular octagon. So we have an octagon. Remember, an octagon has 8 sides. So we have a regular octagon, which has an apothegm of 12.1 inches and a perimeter of 80 inches. So here we're given the perimeter. The perimeter is 80 inches. So we're asked to find the area of that octagon. Well, we're going to use the equation A is equal to 1/2 the apothegm times the perimeter. So I'm just plugging that in. A is 12.1, P is 80. Plug that into my calculator, and I get 484 inches squared. Okay, so if I have that information, if I have the apothegm and I have the perimeter, then I can just plug it into the equation and solve. Okay? But what about if I have something that looks like this, and a question that looks like this? This says, assume that the pentagon is 5 sides. Assume that the pentagon in Washington, D.C. is a regular polygon. How much land does it cover if the apothegm measures 2,882.24 feet and a side measure is about 921? So basically what it's saying is, say that I have a pentagon. I'm going to try. That is not good, pentagon. Okay, I'm trying my best. Okay, that is... Let me just try. I'm going to try one more time. If it doesn't come out right, it doesn't come out right. Okay, that's as good as it's going to get. Okay, so here is my pentagon. It has 5 sides. Basically, what this is saying is my apothegm measures, so from my center to my side, measures 2,882.24 feet. And a side measures 921 feet. How am I able to find my area? Well, the first thing that I need to do is find my perimeter. I'm not given my perimeter here, but I am told what the measure of each side is. What I also know is that I have 1, 2, 3, 4, 5 sides because it's a pentagon. So what I'm able to do to find the perimeter is take 921 and multiply it by 5, because I'm adding all those side lengths together to find the perimeter. And that gives me 4,605 degrees. So now I have perimeter. Now, in order to find my area, I can use my equation. And I have my A, and I have my perimeter now, and so I can just plug that in. Plug that into my calculator, and I'm going to get a very large number. And what that is telling me is what the area is of my entire pentagon, so that I'm able, in this instance, to cover as much land as possible. How much land does it cover? Okay. So in some instances, you may be given your A and P directly, or you'll be asked to identify, in this case, what the perimeter is before you can go ahead and plug that into your area equation. Okay. 1 second, guys. Okay. So what if I get a problem like this? This one says a radius of a regular polygon is a segment from the center to the vertex. So we know what the radius is. So what we're able to do here is, if I want to find the area of this pentagon, this is a pentagon as well because it has 5 sides, what I need to do is I need to identify what A is. Well, how can I identify what A is in this instance, the apothegm? How am I able to identify that if it's not given to me? Well, the way that we can go about solving this problem is, what we'll notice is that this perpendicular bisector bisects this line segment into 2 congruent halves. So those are 2 congruent halves. And what I know is I'm told the measure of each of these sides. The measure of each of these sides is the same. So what I can do is I can take 8.2 and divide it by 2. That's 4.1. And what that tells me is that this side is equal to 4.1 and this side is equal to 4.1. So what I notice here is I have a right triangle where I know 2 of the side lengths, but I'm missing 1. Well, if I know 2 of the side lengths and I'm missing 1, I know that I can use the Pythagorean theorem to solve for the missing side length because I have a right triangle. So I'm going to plug in my information. I'm looking for a squared equals to 49 minus 4.12. Oh, I'll make it like that. Okay, now I'm going to solve. I solve by doing the square root. To get rid of the square, a is equal to, and I can plug this in. Give me 1 second. Plug it into my calculator. Okay. So a is equal to approximately 5.6736. Okay, so that is my a. So that is my algorithm. This equals to. Okay, but how do I find the area? Well, what I also need is to find the perimeter. I have my a. Now I need to identify my p. I find p by taking each of my side lengths. I know each of my side lengths is equal to 8.2. And I know that I have 1, 2, 3, 4, 5 sides. So my P is equal to 41. Now I can find my area. My area is equal to 1/2 what my A is times P. Plug that in. And what I'll see is that is equal to, into my calculator just to be sure. Approximately 11.630. Oh, 41. That's why. Hold on. 41. I put 4.1. Try plugging this to your calculator as well. Okay, and that equals to about 116.31. So that is my area. So I'm able to find the area. First I need to find my A, then I need to find my P, then plug it into my area equation to solve. Okay? So does anyone have any questions here about how I found my A, how I'm getting to my P, or how I'm even finding the area? What equation am I even using? Any questions? Questions, concerns? Okay, that's fine. Okay. So basically, I'm just going to do it again, just to make sure we understand. So this one says the area of a nickel plated should be used to cover the front of this regular heptagonal coin. So heptagonal is 7 sides. You can also go ahead and count the sides. So 7 sides, heptagonal, 7 sides. Now it says, if the radius is 15 millimeters, so radius from the center to one side, if the radius is 15, oh no, I'm going to connect it to a point. I'm trying my best to connect it to a point. Okay, I'll do it there just so it's easier for us to see. Okay, if the radius is 15 millimeters and the sides are 13.02 millimeters, so each side is going to be 13.02 millimeters. am I able to find the area? So I'm looking for the area. What is the area of the nickel plated? So I'm looking for the area. Okay. Well, in order to find the area, what I want to do is I need to find my A, and I need to find my perimeter. So how do I find my A? Well, I know that my apothium is a perpendicular bisector to one of my sides. So that means it would meet it at 90 degrees. But I also know that because it's a perpendicular bisector, it takes one of my sides and it splits it into two congruent halves. That's the idea of a perpendicular bisector. So if I know my halves are equal to 13.02, I can divide by 2 to find out what this missing side is. And that is 6.51. So that's 6.51. Okay, so now what I'll realize is that I have a right triangle there, and I know my hypotenuse, and I know the length of one of my sides, but to find my A, my apothium, what I need to do is, again, use the Pythagorean theorem. So I'll plug that in. A squared is equal to 225 minus, and I need to take the square root. So A is equal to, let me plug this into my calculator again. Okay, that's approximately 13.5137. So that is my A. So now I have my A for my area. Now I just need my P. My P is equal to my perimeter. I know the length of each of my sides, and I know I have 7 sides. So perimeter is equal to 13.02 times 7, which is 91.14. Okay, now I have my A, I have my P. I can plug it into the area equation. My A is 13.5137. My P is 91.14. And when I plug that in, I will see that this is equal to 615.82 millimeters squared. Okay. So again, here what I'm doing is I have to find my apothium. The way I do that is I use the Pythagorean theorem. I need to find my perimeter. How I do that is I take the length of each side and multiply by the number of sides I have, plug that into my area of a regular polygon equation, and solve. Okay, any questions here? Questions, concerns? Okay. So now we're going to look at one more type of problem that kind of puts what we looked at in the first problem and what we're looking at right now. So this one says a regular octagon, first thing, octagon, 8 sides. A regular octagon has a radius of 15.7 feet. What is the approximate area of the regular octagon rounded to the nearest tenth? Well, what you'll notice here is you're not given any information about your A, or are you given information about your perimeter? You're not being told anything about what the length of each side is. And so what you're going to have to be able to identify is a way to find what the length of each of these different sides is. Okay? Because you're not being told anything about that. So it's a little bit different. Well, we're going to throw in what we looked at in the first problem, and that is that you can take a regular polygon and you can create isosceles triangles out of each side. So I'm going to try my best to draw this. And in this instance, you're able to create 8 isosceles triangles out of each side. Okay. And so that being said, what I'm able to do is I'm able to find the central angle measures of each of these isosceles triangles. More specifically, if I had a circle that existed here, in order to find the central angle measure, what I would do is I would take 360, the total interior angle of a circle, divided by the number of sides, in this instance 8, And I would be able to identify that my central angle is equal to 45 degrees. So each of my central angles is equal to 45 degrees, if I really think about it, okay? So this takes us back to the first problem that we looked at, right? We looked at the same thing. We wanted to find our central angles, so we took the entire interior of a circle divided by the number of triangles in this instance, and you're able to solve. So now that I know that all my central angles are 45 degrees, the next thing that I want to do is I want to identify what the length of my A is. Okay, how will I do that? What I'm going to do is I'm just going to isolate this to one isosceles triangle. Give me 1 second. Okay. I'm going to make this one isosceles triangle just so I don't get confused with everything that I'm working with. So this is equal to 45 degrees. What I know is that my A, my apothem, is my perpendicular bisector. And so that means that it would bisect not only my side, but it would also bisect my angle. And so that being said, what I can identify from that is I'm going to go ahead and do away with this. So I created my apothem, which is a perpendicular bisector. And so because of that, I can bisect my original angle. Bisecting it means I can divide it by 2. And I can identify that that new angle, that shortened angle, or that bisect angle is 22.5 degrees. So now what I have here is I have a right triangle, and I have one side of my triangle as well as the central angle. And so because of that, because I'm given one side and the central angle, and I'm not given any other information about any of the other angles or any information about any of the other sides, what I need to do here is, in order to find my A, instead of using the Pythagorean theorem, I'm going to use my trigonometric ratios, which basically allows me to, how do I find A? Well, I find A by using cosine. Remember my trigonometric ratios, so so let me make sure I'm writing this right. So, oh, that's why. Duh. Okay. So, TOA. Why am I using my cos? Because I want to identify what my A is. And my A, I have my adjacent. I have what is adjacent to it, and I have my hypotenuse. Okay. So, I'm looking for my A. So I put it into this equation. This will tell me that my A is equal to and I can plug that into my calculator. And A is equal to 14.5049. Okay, so basically, because I do not have information about two sides, what I need to use is one of my trigonometric ratios and plug in my information and solve for A. Okay, so solve for A. Now I can also use this to solve for B. I can use it to solve for the length of my missing side. So I'm going to use sine for this one. So B is equal to, oh no. Let me see. So B is equal to, if you want to, yeah, that's okay. It's up to you. Okay, so now I have my A and I have my B. So basically I'm finding the lengths of my missing sides. So this would be my B. Okay, and so now I have my A, I have my B. What my B tells me is the length of this side. And so that perpendicular bisector broke up my side lengths into two congruent halves, so I can multiply by 2 to solve for the length of my side. Which is 12 point. Okay, and so now I can find my perimeter because I have the length of my entire side. My sides are equal to, now I plug that in, find my perimeter. I have 8 sides. Times 8. And now that I have all this information, I can find my area. 1/2. What is my A? My A was 14. What is my perimeter? Well, I have it right here. And then plug that into my calculator. One second. And that is equal to 697.18. Okay, so in this instance, you're basically doing the same thing. It's just a little bit different. The first thing you want to do is you want to identify that central angle measure. The reason that I'm trying to identify that central angle measure is because I need that information in order to use my trigonometric ratios. So once I do that, the next thing I want to do is identify that my apothium takes my central angle and divides it into 2 because it cuts it in half. It's an angle bisector. Then I'm going to find A by using cos. I'm going to find B by using sine. Then what I know is that my side length is basically B times 2. I can find the perimeter by multiplying that by the number of sides. And lastly, I have my A, I have my P, and now I can put it into my area of a regular polygon equation, and therefore I'm able to solve. Okay, so this is more of a lengthier process, but basically what your goal is to find your A, find your P. Once you have your A and your P, you can plug that into the regular polygon equation. Okay? Any questions? We'll go over some more example problems tomorrow, but anything right now? Okay, so what did we look at today? We looked at how to find the area of a regular polygon. The way that we do that is we use area is equal to 1/2 A times P. A is your apothium, and that is your perpendicular bisector of your side length. And P is your perimeter. In order to find the missing side lengths, what you need to do is draw a right triangle using a radius or apothium. And depending on which information you're given, the first thing you can do is use your Pythagorean theorem if you are given 2 side lengths. If you're not given those 2 side lengths of your right triangle, then what you're going to want to do is use your trigonometric ratios in order to find those missing side lengths. Okay. Any questions? Okay. If there's no other questions, you guys may log off, and I will see you guys tomorrow. Bye, guys.